Good evening. It is my pleasure to be here today with my collaborator, Dr. Jim Adams, to present our work on microbiota transplant to heal the gut and the brain for autism and Pitt Hopkins. Krajmalnik-Brown was essential in all the research that I'm going to present today. So even though he's not here with us, he's here with us because his data are here too. So our vision is to heal the gut and heal the brain. That's the main vision of most of what we do. Most of you probably know that 1 in 36 children are now diagnosed with autism in the United States. These are numbers by the Center for Disease Control. 40% of children and adults would have gastrointestinal symptoms lasting years to decades. And we also know that worse gut problems lead to worse autism symptoms. There is no FDA-approved medication for core symptoms of autism. In this figure, you can see a human with lots of microbes. That's a microbiome. And on the left side are things that modify the microbiome or that affect the microbiome, or genetics, diet, mode of delivery, the environment, drugs, and exercise. And on the right side are things that are actually affected by our microbiome, like cognitive behavior or stress, some of our social interactions. And you can probably, I want to point out that some of these things that are listed on the left side are also possible causes of the etiology of autism. So this gets together that some of these causes can be interacting with the host and with the microbiome to lead to autism or worse autism symptoms. So we know that microbiome impacts health. At the gene level, we're 1% human and 99% microbe. There's 100 times more genes in our bodies from microbes than from our own genome. And the microbiome has, as I mentioned before, been correlated with a lot of disorders and diseases. Our core research together, Dr. Jim Adams and mine, has established some important links with autism. And so we know that if we can manage the microbiome and we can get to a healthier microbiome, we can get to better metabolism, better GI health, improve behavior, mood, less obesity, and we can also affect drug activity. Our treatment is a therapy to modify the microbiome that includes highly purified, about 99%, gut bacteria from carefully screened and very healthy donors. This is a super probiotic with more than 500 species. You might know that typical probiotics are derived from milk, so the natural habitat of these microbes is milk, not the gut, and they usually have 1 to 10 species. So our probiotic is superior in these two special ways. We did a treatment with a phase 1 trial with 18 children with ASD. And in this initial open label treatment, we were able to show that when we use this microbiota transfer therapy, we were able to, first of all, increase diversity in the guts of the children. So what you're looking at in this figure is FAITH-PD, which is a measurement of diversity. The higher the number, the more diverse the gut is. This green line is typically developing children, which are age-matched and are compared to the children that were treated. You can see here the children started with very low diversity, much lower than the typically developing children, and much lower than the 2 lines, which are our donors. And as the treatment progressed, week 10, which was the end of treatment, we can see that diversity improved. Week 18, which was a follow-up 8 weeks later, diversity was even higher. And even more exciting, we did a 2-year follow-up where we see that diversity was even higher than our typically developing children. So the guts of these children improved dramatically with the treatment. We also saw how similar was the gut microbiome to the donor, which is what we're looking at in this figure. This is a figure of dissimilarity. The higher the number, the more dissimilar things are, and we're comparing to the most recent donor. The lower the number, the more similar things are. So we can see that here's the beginning of the treatment. This is like an average similarity from just a healthy person to another healthy person. We can see that after 3 weeks and after 10 weeks, which is the end of our treatment, the recipients were more similar to their donor than to like an average other person. However, we did see that on our 8-week follow-up, some of this similarity got lost. And at the 2-year follow-up, this similarity to the donor was lost. And so we here see that although the recipient's microbiome colonized initially, at 2 years later, these children had a microbiota that was really different to their donor, but had a more healthy microbiota and really good improvements, which was the goal. And so here you can see some microbes that are important microbes that change during treatment. Bifidobacterium is a known commensal and a non-beneficial microbe. We can see here in the beginning before the treatment, it was much lower than our controls, and it increased with treatment, and it increased even more after 2 years. This is one of the beneficial microbes that increased even after 2 years. Prevotella is a microbe that we've been following because we found that it was a very low abundances in children with ASD compared to typically developing children, which is what you mainly can see here other than these 3 children. It increased with our treatment. It increased dramatically after treatment, and this is one of the microbes that their abundances came down a little bit after the follow-ups. And the sulfobrubic is another microbe that we've been following, even though it's not considered a beneficial microbe. And with this, I will pass it to Jim, to my collaborator, so he will tell you a little bit about, I showed you that we changed the microbiome. Now he's going to tell you about what were the behavioral and GI changes with these changes in microbiome.
Thanks, Rosie. So again, we're so grateful to University of Minnesota, to Dr. Alex Koritz and Mike Sadowski for providing the microbiota that we used for our studies. We saw that the microbiota transplant greatly improved both GI and autism symptoms. We see on the left the slide the plot of GI symptoms versus time, and we see that there's an 80% reduction by the end of treatment. 8 weeks later, it remains improved. Even 2 years after treatment had stopped, there's still a substantial improvement compared to baseline. But what's even more exciting is the improvement in autism symptoms. Autism is generally viewed as a lifelong incurable condition, but initially there was a 23% reduction by the end of treatment. And 2 years later, many families reported their children just continued to improve during the 2 years post-treatment. So they started at the start of the study, over 80% had severe autism. By 2 years post-treatment, less than 20% were severe, roughly 40% mild to moderate, and 45% had symptoms that did not qualify for even mild autism. So just great improvements in this open label study. And the FDA granted us fast track status based on these initial results from our phase 1 study. Next slide. Next slide. And so we then did a phase 2 study with a grant from the federal government. It's a very rigorous, randomized, double-blind, placebo-controlled study. We found that the treatment was very safe, actually safer than placebo, that the treatment group had fewer bad days of symptoms than the placebo group. We found it was very effective. The 10 weeks of treatment led to a medium effect size, a medium improvement in symptoms, and an extra 8 weeks of treatment led to even more improvement in symptoms. And the GI symptoms improved substantially as well. We're now working on planning to optimize the dosing for that study. For treatment in our next study, we've learned some major clues about how to improve dosing. And bottom line is these results for a phase 2 study are certainly enough to justify moving on to a phase 3 study as well, and that's part of our next plans. Next slide. And so this just shows a plot versus time of the severity of autism using the CARS rating scale. The bottom line at 28, below there is below the cutoff for autism. 15 would be perfectly normal. And 35 is the cutoff for severe autism. So we see in the blue line, people on average started in the severe range. By the end of treatment at part 2, they were down to moderate symptoms. And over the next 18 weeks, symptoms continue to improve down to the mild range. So that's huge to see. And then in the red line, the first segment is for those who who were just on placebo, not much change. Then they were switched to 8 weeks of treatment and they improved. And then we followed them for another 18 months. And those improvements generally remained, but not as much as those received the longer treatment. Next slide. So the bottom line is we've learned a lot from these studies. Many, many thanks to Dr. Alex Koretz and Michael Sadowski for their pioneering work in developing these capsules. And many thanks to ACT and all of you for your support of ACT, which has helped UMN produce these capsules and to help support us in our clinical trials to get this treatment approved for autism. If you want to learn more about our work, you can contact Dr. Rosie, or you can go to the website for the company we formed to bring this to market. Thank you very much.